Hey, so this video is about an hour long. So if you don't want to watch all that, here's a 60-second summary. Hi, I'm Ian, and this is a video about what I've been up to for Q4 of 2023 in my home electronics lab. This video is dedicated to Angel, Poncho, Vince, Seth, Sandy, and Blake. Nothing that I have done for the last 5 or 6 months would have been possible without all of their help. So I think the best way to start would be a tour of my current lab setup, the shape and structure of all my equipment and the way it's organized changes probably once every other month. I'm packed into a pretty tight space for how much stuff I have. So let's do it. I'm pretty happy with my room right now. It's not super messy, but it was, and that's why I cleaned it. Back in October, the project clutter from these shelves was basically strewn all about the room, and there was basically no space whatsoever to walk around in. I built this little standing desk that I can put together. It's got a whiteboard on one side, and I installed some LEDs on these shelves, so that's pretty cool. And then all my components up here, and then I've got my tools down in a bin, my other bins, and then my tool bag. Here's some of the most recent signs I've been working on, and now we're going to go into the closet. So the reason it's shut with an air purifier in front of it is because I've been printing these orbs round the clock in ASA for several months now. So they're both printing the exact same G code, prints 9 halves of the orb. Oh wait, that one's failing. 9 halves of the orb, so put them together, that makes 9 orbs. And that takes about 16, 17 hours. I've got 2 spools of 5 kilogram of ASA, and I've gone through at least 12 of these by now. This is my Prusa. Then, extra cables, boxes for shipping, and tons of extra spools and garbage and all that. This is a carbon filter that kind of helps mix the air around, and I think it used to help purify, but it doesn't really anymore. But anyway, so this first rod is hanging by these little clips with the string, and then that clamp right there prevents the rod from rotating, so that only the spool rotates, and then that feed goes into a little piece of PTFE going through the wood there. Then it comes out and goes into printer B. That one's doing fine. Then this spool is actually on a crowbar that's just perfectly suited for the job, and that one goes right in there. It cuts between 2 other spools, so I put another piece of PTFE there, but it really doesn't have to go there. But anyway, this room is poisoned, so I'm going to get out now. So coming downstairs, we have my dedicated corner for the rat rig, and this has gone through several evolutions in the last couple months. One of the big things I'm going to talk about is the troubleshooting, the maintenance, the upgrading, and the fact that I rebuilt this whole thing from scratch. So I'm going to open the front panel real quick. So on the inside here, I have these 5 LED panels they were originally part of kind of a folding star shape, and I basically just ripped out all 5 panels, extended their wires, and then ran them into the back. So this provides permanent lighting in here, and it works really well. I also designed this really basic webcam mount for the webcam, and it kind of follows the same line up there. A big reason I had to rebuild the entire rat rig is because you need to replace all the printed parts with ASA or ABS if you want to have enclosed heating like this. I found that the temperature of the chamber does not really get so high that it would cause PLA or PETG to deform, but you don't want to find out. During my teardown, I also replaced the gantry rail with a carbon fiber, but I have yet to replace the linear rail with I think it's MGN 12, and then I'm going to replace it with a 9 so that it's even more lightweight. And in the near future, I plan on rebuilding the whole hot end with the new rat rig tool board. And that also will allow me to do CAN bus so that I don't have to use this awful drag chain anymore. Look at how many wires are going down here. This is ridiculous. One of my most recent mods is I took these little panels that kind of make it airtight, added some extra duct tape to attempt to make it more airtight. But I put this little exhaust fan. So now that can suck out the fumes when I'm printing ASA. And coming out here, that little exhaust fan right there has this ducting, and so the duct can go out the window over here. And so this works with some success. It's not perfect. You know, if I print ASA, you're still going to stink up the house, but less poison is better. That's what we shoot for. And I'll include some pictures, but this used to be covered in whole bottom used to be covered in failed prints or just scrap from testing. Up here I have this little plastic tote holding my filament. There's also a dehumidifier in there, but it's not plugged in because it doesn't do anything really. Then coming down here, I have all my cables. There's a filament dryer. And then this bucket is actually full of my spare parts and my future mods. Looking at the wires themselves, this black thing is the original structure for the light panels. And the PCB is still in there. So I could take this out and rehouse it. I just haven't bothered to yet. And you see this huge, uh, needlessly thick umbilical. I also added some zip ties and a cut up dowel to mount this little 12-volt fan. And that keeps the stepper drivers for the XY motors nice and cool. Sometimes they do get warm. I also have this extension cord right here to manage everything so I can kill the power very easily on this. And then I have this PTFE mounted into the hole in the side of the tote here. Comes over into the filament sensor. And this is the BTT Smart Filament Sensor version 2. It has the run out so that it can tell when there's no more filament, but it also has the motion sensor, little Hall effect sensor in there so that it can tell when the filament stops moving. We'll talk about why that's important in a few minutes. But yeah, that's pretty much the state of the rat rig. It's currently in good shape. Very set and forget type printing at the moment. Not too inclined to mess with it, but I will because I love shooting for more. So that's enough of that for now. And finally, we have the garage. So this has also gone through several iterations as I attempt to produce these steel balls. Currently, it's kind of a mess. It always reeks of paint fumes, but yeah, I also have a lot of spare garbage. The gist is, here's the workstation. This is where I take the two orb halves and assemble them. Then I cook them in this container. Then I hang them to dry over here on the drying rack. Once they've finished drying after cooking, they're ready for paint, and so I will bring them out in small batches over to the paint rack. I've got plastic tarps everywhere for this purpose, and you can see where I've been painting. All the paint lands just behind where the orbs hang. Then I move them back over here to dry in between layers, and currently we do have a whole batch of finished orbs curing their gloss coat. So these guys look real nice. Pretty happy with these results. So that's the garage for now, and more on this in a bit. So around October, I think it was, my buddy Poncho hit me up and he asked, how many of these orbs could you print a day? And I was feeling pretty confident in the capacity of my printers. They're about the size of a baseball, so I threw it up on my slicer and I saw, okay, I can print a 4x4. I think it's a 4x4. No, a 5x5, 25 on each of the Cobras in the closet. And then a 6x6 on the rat rig. That would amount to something like, what, 80 orb halves, maybe 40 orbs a day. Obviously, that didn't happen. But from there, I needed to figure out how to smooth these orbs. Want to get rid of the layer lines, put a badge in them, combine the two halves, and then paint it. And then we wanted to do a production order of 500 of these. And, that sounds like a lot, but the complexity of the task was only revealed progressively as we continued kind of exploring and doing some prototyping, little bits of R&D here and there. Come on. Sorry, Miso is currently bringing in his stuffed elephant. Anyway. So I started by printing them, and I'll put pictures up. I started by printing them in PLA, and then I followed some guides for people who build like cosplay props and stuff. They basically sand it down with progressively finer sandpaper, and they also mix wood filler with acetone and then kind of wipe it on the surface of the sanded print in order to fill the small gaps. And then after a few more passes of sanding, the whole thing should be perfectly smooth. The problem is the steel balls, these orbs, they have these grooves. Here's one. They have these grooves, and those grooves are rounded. They're not sharp. And so how am I going to sand something like that at that level of fine detail 500 times over and over and over? Well, the answer is I'm not going to do that. So I immediately switched to, after doing this like 5 times in my backyard with PLA, I switched to ASA, vapor smoothing. But I had never printed with ASA, and I didn't know anything about vapor smoothing, so I watched a bunch of YouTube videos on it. And a lot of people do not use heated or pressurized acetone chambers. They might do one or the other. I only found one person who does both because he makes 3D printed instruments, like recorders, I guess. And that's really cool, actually, because this stuff is dimensionally accurate enough to produce, music, good frequencies. So I started experimenting, bought a gas mask, bought a few gallons of acetone, kind of went on some Breaking Bad stuff. Lots of fun. Eventually, I tried just soaking. I threw one of the orbs printed in ASA just straight into an acetone bath, plunged it, and when it came out, it was so smooth. I have not been able to replicate that smoothness on anything since, but I've been able to approximate it. The process that I settled on is I put a bowl on a hot plate and I fill that bowl with water. Then I put a little lemonade pitcher inside that bowl, and the hot water cannot exceed 100 Celsius because it's water. That's important, actually. The water acts as the medium of heat transfer to the lemonade pitcher, which is where the acetone goes. Now, acetone, it boils off. I haven't looked up the number still, but it's got to be somewhere around 60 or 70 Celsius. And if you put a part made out of ASA hanging inside that chamber and seal it off, what'll happen is the acetone will evaporate and then it'll recondense on the surface of the print and probably drip along the way. But when that acetone recondenses on the surface of the print, it chemically dissolves that surface. And so the layer lines melt together. So if you kind of dig in maybe 1 millimeter into the next couple layers of the shell, you will see the layer lines there. But on the outside, the layer lines have all melted together to form one continuous piece of plastic. And that actually makes it a lot stronger. ASA is also stronger in general than PLA or PETG. After you acetone smooth it, it can really take a hit. One issue with these orbs, let's see if I have an unfinished one. Oh, I do actually. One issue with these orbs is I printed up from the equator. And so the layer lines, you can see, go across, I guess these would be whatever bands. And so you can actually chop it across right here. You could karate chop and basically take off its head. And so if you strike the orb onto something, there's a good chance that it'll just slice right off. And that's obviously not what you want, even though it's supposed to be a prop and not a weapon. If anybody who purchased a steel ball is watching this video, don't complain to me if you break it because you swung it at something. It's a prop, not a weapon. Anyway, the acetone smoothing actually totally gets rid of that problem, makes it really, really strong. Way stronger than the PLA and way stronger than the unsmoothed one. So that's a huge plus. Another aspect to that is I can actually acetone dip the chew halves at the equator and just smush them together. And that bond is actually really, really strong because, again, it forms one single piece of plastic. Before, when I was doing PLA, I was actually using epoxy to bind them together, and the epoxy is just too sticky and it takes forever to cure. Whereas the acetone dip, it's probably done within maybe 5-10 minutes. The only issue is I need a key. I do have slots and keys. You can see here, there's a little rectangular gap there. And so I fit the key in there, and then I dip it, and then I smush them together. One further complication is the badges. Let's see if I have a badge. Yep. The badges are mass manufactured as well. And so the black plastic casing here and on the nib at the top of the string, these guys both dissolve when exposed to acetone. So now I have to protect the badge at all costs from acetone, but I do dip it in acetone. So there are some quality control issues here. First, the badges are cheap, super duper cheap, and so some of them show up broken. Then when I dip it in acetone, some of it manages to get on the string and then drip into the internals of this badge. And there are plastic parts there that are functional to the spring or holding the spring in place. And so if those dissolve, it's game over. And I have had that happen at the final stage of the orbs a few times where, it literally looks like this. And then the string finally gives out. So I could have, I guess, the solution there is to invest in better badges in the first place, but the process has already been built around it and it's too late. So the orbs are the primary thing that I've been working on the last couple months. The other primary thing would be the rat rig. I have rebuilt the rat rig from the frame all the way back up, mainly to replace the printed parts, which I believe were made out of PETG originally, with the kit that comes from rat rig. and I reprinted them in ASA in a nice light blue and rebuilt the whole thing. I also got some square brackets so that I could make sure that the frame was absolutely square, because before I tore it down, I actually found out it wobbled a bit on one of the legs, like an old chair. And I didn't spend all this money and all this time building something for it to wobble like an old chair. So to get to the bottom of it, I basically spent several months calibrating, recalibrating, breaking parts, wondering why they were broken, doing lots of research, and I was just getting absolutely terrible results out of the rat rig, and wondering like, how am I spending so much time and money on something that works so poorly when the printers in my closet, they cost maybe 1/5 of the price at most, and they work so consistently. Granted, the quality isn't as great as the rat rig would be at its peak performance, but the rat rig's performance was so inconsistent, I was tearing my hair out. And I knew that like other people are able to do amazing things with this printer, but I'm not, which means I must be missing some sort of critical information. The critical information was, it's embarrassing. My extruder steps per millimeter were miscalibrated. They were pushing 2% more filament than they were supposed to. And most 3D printer calibration guides start with that. And I did do that at the beginning, but I did it lazily and with a degree of precision inappropriate for the impact of miscalibration. Because I bought the rat rig 500 millimeter because I print these neon signs. These guys. That Las Vegas Aces sign is 27, 28 inches tall. I print it diagonally on the 500 millimeter bed. I can print that in one piece. It's awesome. That's why I got it. But the problem with very large prints is that they take a long time. And if you have a print that takes a very long time and your extruder steps per millimeter are tuned to over extrude by 2%, over time that extra 2% will compound and create catastrophic failures. I tried to print this Guts Berserk helmet, which when I did finish it came out awesome. The first time I tried to print it, it literally snapped the hot end off of the heat break. It broke the metal to metal screws. And what happened was the over extrusion caused the print to be taller than it should have been for that given layer, which meant that the nozzle was starting to strike when it traveled, and eventually it started grinding whenever it tried to print because it was getting smothered by a tall print and it was digging into it the whole time. And when it gets smothered like that, it is also unable to extrude. This issue I was able to fix down the line by adding the smart filament sensor, which has the motion detection. If that scenario ever comes up again, where the nozzle is getting smothered by the print due to over extrusion, the filament will stop moving through the nozzle, and then the filament sensor will notice and it'll just pause the print. When this catastrophic failure happened, I did not have the smart filament sensor, and my extruder steps per millimeter were still way too high. So I let it alone overnight, and then I woke up and I decided to check RadOS on mobile, because that's basically my morning ritual now. Is I just grab my phone the moment I wake up, I open the browser, and I wait for the webcam feed to load, and then I see what sort of ridiculous failure I have to go solve first thing in the morning today. That was my life for probably at least 2 months straight. It's not that anymore, thank goodness. But anyway, that morning I woke up and it said that the got a weird signal from the thermistor on the hot end. It freaked out because the temperature wasn't what it expected it to be, and so it paused. So I thought, okay, well, that sucks. Now I got to restart the print. Then I go downstairs and it's nightmare. So I decided, okay, you know what? I bought this printer and I wasn't that serious about doing all the research. I, assumed that it would be hard, and I assumed that it would take time, and I was putting in effort and putting in time, but I was not putting in the level of care necessary. So once I started doing that, I learned all sorts of new things. Too many deep dives on like linear rails and belt tension and input shaper and pressure advance and all the other kinematics behind like Core XY. I've basically become like a one man F1 pit crew for the rat rig specifically. All this to eventually figure out, like, you know what, the issue has to be the extruder steps per millimeter. That's the only thing I haven't checked in a few months. And lo and behold, yeah, 2% is all it takes. Especially, so the big takeaway for this video, for anyone that doesn't know me and isn't watching just because this is a substitute for my like lab posts. If you're just like another person who has a 3D printer, if you print something that takes longer than half a day, 12 hours, just double check your extruder steps per millimeter. Instead of doing like 100 millimeter extrusion with the 120 millimeter mark, do it at like 300, 300 and 320. You'll triple, probably, I think, the precision. You'll increase the precision no matter what if you do that. And just make sure that it's very finely calibrated. Otherwise, you will have nightmares, especially with self-built 3D printers. I found that, these kits that you have to build yourself, they are at least 10 times the complexity, 10 times the difficulty level of troubleshooting and managing, something like the Cobra. The Cobra Max, it shows up pretty much pre-built. You have to add like 4 screws, and then it's ready to print. It's amazing because, if I wanted to start a print farm, which is what I have turned into, if I wanted to start a print farm, I would have just bought an industrial shelf, and then I would have bought a bunch of the Cobra Max 2s. But I wouldn't have learned, and my lab projects are about learning first and foremost. The fact that I have a revenue source from these neon signs and these steel balls and other cosplay props now, that is just incidental, and it's just a nice cushion for me to continue doing this type of work, but have a little bit more justification for purchasing the equipment. It's basically just to offset my disposable income getting black holed into this room. But anyway, the rat rig finally works, and I'm looking forward to making it work better and better. It will eventually be super fast. Race car status. I wanted a race car. That's why I bought it. I saw, I think his name's David. I saw David's video, and I was like, I need that. I need it right now. And that's basically why I bought the kit. And to have such a hard time getting it to print at like, I don't know, 120 millimeters per second when his can go at like 450, no problem. No questions asked. I really was wondering for a while what I was doing wrong. I did figure it out, it looks like. But anyway, that's enough about the rat rig. Now let's talk about that helmet. So I had my friend Seth approach me a few months ago, also in October. And he wanted to go to some con in Oregon, and he wanted this Guts Berserk helmet. So he sent me the STL for it. And apparently, this 3D printing firm was going to charge him like $500 to print it, which I can kind of understand. It's such a large print that it's basically like specialty equipment. But part of the reason I bought the Rat Rig 500 was to be able to print things like this. And so I decided to just take the opportunity, do it at cost, which is only like $100. Well, it cost a lot more after I broke the hot end. Let's put it that way. But the material cost for just 2 kilograms of ASA or whatever, for the print and the supports, and then like a $6 can of spray paint. Anyway, I went for it. It broke my printer twice, and then I had to put it off and do all that calibration, and so he didn't get it in time for the con, but I did ship it earlier this week. It came out pretty awesome, especially for my first time doing something like this. So basically, I printed it, but then the supports fell over. And I have a mini. Hold on. So here it is in blue. And so I printed it, and so there, the supports, they go on the inside of the helmet to support the cap at the very top. They kept falling over, and when they fall over, it just creates a huge mess, and it's going to become a spaghetti monster. And so I would actually just cancel the print at whatever layer that it failed at, and then I would go into the slicer, visually approximate that layer, cut off the bottom, then reprint. I ended up doing that in 3 pieces, and so when it was finished, I basically just took those 3 pieces and wiped them down with acetone and then smushed them together just like I do with the orbs. And that actually worked really well. One problem is if you look really closely at the helmet, the finished product, you can see the seam because the layer selection was imperfect. So some layers are repeated. I don't think they were skipped on either of the connections though. From there, I used a soldering iron to try to hide the seam, but I pushed it too deeply. What I learned is, use the acetone to bind them. Use the soldering iron not for structural bonding, but just for cosmetically removing the seam. After that, some sanding, some filler, some sanding again, and then some spray paint with paint and primer. And it looks awesome. It's huge, and I could do it again super easy no matter, like, I feel super confident now. I do need to calibrate my supports a little bit because they did fall over both times I tried to print it. So a little bit of support configuration, and I think I can do like really huge props now. For the acetone smoothing, I have a slightly different method. The orbs, they fit inside a small lemonade pitcher, but for big props like this, I need basically another 500 cubic millimeter or 500 millimeter cubed volume. I don't have anything like that right now. I tried getting a trash can. The trash can, I do believe, will work eventually. But for now, I have a tote, and I put bolts in the side of the tote on the walls so that they can suspend the print. And if it can't hang on the bolts because it's too small, I'll just hang it from the lid. And I figured out I can actually just put that on the heated bed. When I put that on the heated bed, I just pour acetone into the bottom, and then I set the heated bed temperature to 70 or 100 or whatever. And yeah, works perfectly. So I left it in there for about 45 minutes, grabbed it with some gloves, flipped it over, and then set it out to dry for a bit. And then after that, like I said, sanding and painting. So that worked really, really well, and I'm very happy with the results. Very much hoping that I get to do more stuff like that in the future. As far as the signs go, I did some firsts in the last couple of months. I had the Dallas Cowboys and the New Orleans Saints. I don't have good pictures of this, but basically, the client did ask for a plate to fill the negative space in the middle. I could have, printed it with, like a 5% infill or something and filled up that whole space from top to bottom, but I thought that would needlessly increase the mass of the print, so I decided to try out the plate angle instead. Binding the prints together was pretty tough because I print my stuff in PLA unless I have to print in ASA because, fumes. Um, and so I had to use epoxy to bind the plates together, and the epoxy ended up kind of seeping around in from different corners and making the whole thing sticky and kind of gross. And that affected the surface texture of the plate, so I ended up having to put another plate on top of the first plate. So the takeaway there was use super glue, not epoxy, if you can get away with it, because it's a little cleaner. I also basically rebuilt, redesigned the channel system. I was shipping out some signs that were just a little too flimsy and a little too frail. I decided that the channels and the mechanical rails that bind them together were too thin, so I basically doubled the size of it. They're twice as thick, significantly taller, obviously significantly more massive. The signs are much heavier now, but they are much sturdier. I'm really happy with it. I did try printing them with 0.8 millimeter nozzles at one point when I was troubleshooting with the rat rig, and 0.8 millimeter is the future, I think, for these things. The only reason I haven't switched to zero point 0.8 permanently for the rat rig is because I still use it for printing things that are not the signs. But if and when it's in better shape, I think the lower print speed, the lower acceleration, and the higher throughput, I'm printing the signs at least 40% faster with zero point 0.8. And they come out just as good. The 3D printed frame that the light strips rest in becomes completely overshadowed the moment you turn the lights on. You can't tell what color it is for most of them, let alone like subtle details like whether it was printed at a 0.4, 0.6, or 0.8. I also did my first LiPo battery sign. It was also my first RGB addressable sign. And it was also my first magnet snap sign. I made like little enclosure pieces with magnets installed in them so that you could kind of lift and pop it off. That was pretty fun to play with. I also have been working with my friends Vince and Sandy. They've been helping me out a lot. I taught Vince how to do the Fusion 360 modeling for the channels, and he's been taking that over from design phase now. And then we also brought Sandy in because he figured out a trick in Adobe Illustrator to basically produce these dimensionally accurate vector graphics such that when we import them into Fusion 360, I would say 30, 40, sometimes 50% of the work is already done. And so there's more people involved, but the process is much more streamlined. Personally, I'm pretty happy about it because, once we get a design finalized with the client, I pass it over, Sandy, Vince, back to me. I print it, I wire it, we're out of here. So, depending on how, my marketing efforts go in the next couple months on like TikTok and Instagram and stuff, I might be able to get somebody to cut the strips or at least solder them for me. That would be nice. But other than that, I'm really happy with the way the neon signs are going currently. And I basically just need to keep spinning this wheel until I have enough money to pay off all this lab equipment that I purchased. Um, but yeah, I mean, like the contract with the steel orbs, steel balls, that was a lot of money. And my lab has basically ballooned out of control since then. It's been the primary thing I've spent my time on for the last 5 months or so, which is nice. When I started my electronics lab, it was just me on the floor in my girlfriend's room because I didn't have my own place with like a box of resistors. And I was like, this is an electronics lab. Delusional. But you hang in there and you get something like this eventually. Uh, Probably. So moving on. Let's see. I think I had some other stuff. Um, what did I learn? Big thing I learned: the acetone vapor smoothing. There's not a lot of science to this. I mean, there are because there are industrial solvent sprayer chambers or whatever. But that stuff's pretty wrapped up. For what you get for hobbyist 3D printers and stuff, it's more craft than science. And I mean, that is my experience. Like, when you overheat the lemonade pitcher that contains the partially dissolved print and the clouds of acetone, if it gets hotter than 90 or 100 Celsius, the surface of the print, that chemical mixture of acetone and ASA, that mixture starts to boil and those bubbles pop on the surface and ruin the surface because they will cool and then you'll have craters. It'll look like the moon. So that's why I put the water there, because the water acts as like a temperature limit, an upper limit for the temperature. And that's just a really good example of like the craft element to this. I'm also really happy that I figured this out because most of the people who do cosplay props and show it on YouTube, with their 3D printers, they are doing it with PLA and they are sanding it and then filling it and sanding it and filling it and sanding it. It's like, I'm not going to do that, especially with like fine details. Like when you blow up this helmet, there's so many little nooks and crannies, and it's like you're delusional if you think I'm going to do that more than once and risk, scuffing the print permanently and having to start all over. Not me. I don't have the finesse or the patience for that. I have patience for other things, but not the finesse at the very least. And so the acetone vapor smoothing, I think, is going to produce more durable, both mechanically and environmentally, and smoother parts overall. So yeah, I really want to find more people who want cosplay props, and I'm happy to make them. What else? So here's some other niche things that I figured out. When you have a double XL bed like mine, 500 millimeters, even heating is really important. People say that you're not supposed to print PLA in an enclosure, but I have found that because the rat rig, as we saw earlier, has a front door, if you leave that front door open, there will be a thermal gradient from the front to the back of the bed, and that can cause partial or differential cooling on the print, and that cooling can cause the print to contract. And instead of warping off of the bed, these prints are firmly glued down because I use bed weld, because I really need a good first layer because they're huge. They're firmly glued to the bed, and so the bed is flexible. And so when they warp, they actually just lift the bed. because there's a magnetic sheet underneath the flexible bed that it kind of magnetizes to. So when the print warps, it lifts up the whole bed, and your print is over from that point. You can try and save it, and I have reached in there and clamped down with my fingers to kind of counter the warp and bring it back down to the floor, and I have had like very small success with that. But the prince is over. You can't fix it because in the amount of time that you have the door open, in order to do that, the cool air is going to rush in and the hot air is going to rush out, and you'll have issues. I didn't have this issue as bad before I put the panels on, but it still did happen for sure because you move around your house. This is not in a thermally controlled environment, and so once you put all of the enclosure panels on, including the door, the environment becomes very evenly heated and the air is very still. Even with the exhaust fan, it still stays very evenly heated. And so I found that's essential for these large prints, these large sign prints. Um, I don't get any warp anymore, not on my PLA stuff. Another thing is ASA, they say you need an enclosure and don't use fans. But once you have the enclosure, you can use fans. I can turn it up to 100% and they don't care. Another thing is I replaced the PETG parts for the rat rig, the tool head, and all that with ASA. And there's a lot of placed hex nuts all over the place. And when you put a hex nut inside an ASA printed slot, it can strip the slot. And so it stops being a hexagonal socket for the nut to rest in and starts becoming a circular one. And once that happens, the nut is useless. It'll stay in place, but it'll just spin in place and you can't actually tighten the screw in a meaningful way anymore. That's just a little quirk that I noticed. Another thing, I bought 5 meters of fake PTFE. I don't know what it was made of. It might have been, you know, actually PTFE, but maybe the dimensions were wrong, but I couldn't push the filament through with my hands. I had to try really, really hard. And that hurt my hands. And I kept pushing the filament and it would fold and buckle. And then once that, thin spot is in the filament, it's pretty much a risk at that point that it's going to break once it reaches the extruder gears. So that was frustrating. I also do not like, here I have one, the Rat Rigs probe mount for the inductive probe. I think it's the Pinda. This guy right here, this thing pisses me off because you put the two screws right there to pin it to the wall, and then the probe goes into this cylindrical slot with the bottom, the inductive piece coming out there. And so it's held in place at whatever vertical level you adjust it to by one screw right here. Now there's two problems. First, you have to get a hex nut into the cylinder right in the middle there, and I can't do that. I have tried like 5, 10 times. I've only gotten it once. I have to ask Angel to do it every single time. And it has happened more than one time because if your printer is working at meaningful accelerations, the rattling around will eventually cause this single screw to loosen up a little bit. And if this single screw loosens up a little bit, then it is possible for the inductive probe to slip down even just a fraction of a millimeter. And the nature of using an inductive probe is that it is maybe 1 millimeter higher than the nozzle. And so if it manages to fall down because the screw slipped from the acceleration and vibration, then eventually the inductive probe will slip down and maybe your Z offset will get messed up by a few tens of micrometers. Or in the worst case, it'll fall below the nozzle and then strike the print, and now you have a real problem. It's happened at least 3 times now where, I just come down and the probe has broken off. The probe itself, the electronic piece, it's just fine. But because the probe has slipped down and struck the print, and my prints are big, so they do not budge, this thing budges. Um, the probe will slip down, snag, and then crack the print right here in between these two mounting screw holes. And so I have a couple of these extra printed on hand for when that happens. And I just think it's a design weakness. But I did buy the beacon scanner, and I can't wait to put it on. It should be super fun. So those are some just little things that I learned. Some wisdom, some takeaways. Uh, First, I have had a lot of headaches, and I wanted to give up on the rat rig, even though I put hundreds of hours and thousands of dollars into it. But now that it works, I feel better, which I knew would happen. But also, it reaffirms my observation that the best way to learn something new or to get better at something is always to just throw yourself headfirst into the deep end. And it sucks, and it can border on traumatic at times. And it feels like you're wasting a lot of time and energy and money. Um, and you are. You can argue that it's not a waste because you learn so much faster. But you could compare it, I guess, to the oil, like the big ships, the freight ships that move stuff around internationally. They actually move slower than they need to for better fuel efficiency. So they get there, and they're guaranteed to get there, and they waste very little fuel, but they don't get there very fast. If you want to go fast, you end up becoming less efficient. There becomes more waste. And I have wasted time. I have wasted money. I have redone many things that take several hours to do. I have spent several $100s that I did not need to spend, or several $100s in equipment that I then immediately broke, that type of thing. But there is no way that I would have learned as much as I did in such a short period of time unless I had the time, energy, and money to just keep throwing whatever I had access to at the wall. And, no matter how upsetting it was that I had to deal with these losses, if you have that stamina to push forward, you will learn faster. Another thing, similarly, if you want to make money, uh, you need to stop yourself from overcomplicating things. And obviously, like when I'm learning and troubleshooting and trying new things and experimenting, you create waste. Creativity takes waste. Uh, Efficiency is what you want when you're trying to make money, because you want to spend less money and spend less time and keep the process as simple and as predictable as possible. That is an environment where you can be creative, I guess, in setting it up, but it actively resists creativity once you set it up. That is not the way I've arranged my lab. It is still a place of creativity and learning. It is not a place of production and business. If I wanted to make the most revenue for spending the least amount of time and money, I would have bought more Cobra Maxes, as I mentioned earlier. I would have never even looked at the rat rig. And I probably would have refused an order that would require me to uh, make a mechanical toy. There's two big problems with it. One, it has moving parts. This is a real thing with like mechanisms and stuff. The helmet, it's not mechanical. It's just a helmet. It's You can make the helmet faster than you can make a single orb. Along with that, this has 5 layers of spray paint on it. I have a gray primer, green enamel, then a copper green color shift glitter, which is what you're seeing, as well as a glow in the dark coat, and then finally a gloss coat to keep it all in and protect it. Spray painting is expensive and very labor intensive and a lot more skilled than I was expecting it to be. So keep your processes very simple if you want to make money off of them. If you want to explore, don't do it for money. Use your own money and use your own time, and don't try to put a deliverable on it. Let's see what else. Along with that, if you want to sell the things that you make, knowing how to charge for them properly is also um, a skill that I am learning. All right, so what is next for these projects? What is next for me? And what is next for this video making, this channel? So for the rat rigs, I have a small set of mods that I want to add. I need to make a heat set insert machine, and then I plan on building the enraged rabbit carrot feeder. I'm going to put on the MGN9 rail on top of that carbon fiber to make it extra fast, and install the tool board with the CAN bus, get rid of the drag chain, and then just run a USB-C all the way back. I'm probably going to get a different or better webcam, and I am going to rethink my lighting solution because I'm not a big fan of it right now. And I'm probably going to rotate the webcam 90 degrees because most of the time lapses that I'm recording, I'm just going to put on TikTok anyway, so they need to be vertical for a phone. Other than that, I'm going to continue marketing the signs and try to find my way into making more cosplay props. I have a series of sign designs that are all anime based that I plan on just printing the time lapses of me making them, and if people want to buy them, I will sell them to them after they've been made, which runs contrary to my custom order only methodology so far. But even if nobody buys them, I'll have about a dozen anime designs that I can take to a table at a local con or something like that. And the same runs true for cosplay props. Um, I helped my friend print some Honkai Star Rail character's weapon. It was a bat. And the deal was like, this guy knows Blender. And he's like, I'll make the bat if 20 people give me, however much I want to charge for it, $20. And it's like a Kickstarter. If he doesn't get enough people, then he doesn't do it. And everybody gets their money back. I thought, that's really smart. So now I want to go find a guy who knows Blender and just kind of offer that full service. So, we pick a prop, we do the Kickstarter for the file. Then we also offer to print acetone smooth and prime it, or even paint it if that's what they want. And I think that's probably good money. It's something too where like I said before, I don't really see people exploring that niche with the ASA and the acetone vapor smoothing. I think that might be because it's more of an engineering approach than a craftsman or like a crafty approach. But I mean, I guess we'll see. For me, I naturally oscillate in my lab work between phases of building and phases of studying. And I have been building for much longer than I have wanted to be building. I want to sit down in my computer in a clean room without an active air purifier, and just like, I don't know, do some courses, watch some videos, program some stuff, read a book. I haven't been doing that for months now, and I really want to not build something for a bit. I do have some friends that are trying to get into game dev, and they want me to do that with them. So I might go make a game. I have a couple game ideas. Um, but yeah, I'm probably just going to be reading Art of Electronics again for a couple months. Um, for this channel, if people like this video, they think it's worth watching versus the bi weekly updates that I do on my website with the text and the photo dumps, I might keep doing it. Otherwise, if I wanted to do YouTube more in earnest, I'd have to produce high quality videos with better editing. But I do have a couple ideas. Let me know what you think. One is I go find other people's projects on YouTube and I try to replicate them. I'll probably come up with a slightly different product or a slightly different design, and then I can kind of post maybe like a response to what they did. I think it'd be a good way to learn new things and kind of explore territory that has been lightly treaded upon before, and also possibly network with other people who are like me. It might also be a fun way to start some drama. Then, otherwise, I have an idea of just taking basic stuff that people have already made before, like lamps or like a kettle, something like that, and just kind of like redesigning them from scratch, kind of making my own version of it. It is trivial, it is reinventing the wheel, but it is something where I could definitely kind of like grind the XP, building these fully contained systems, using my electronics, using my 3D printing. Uh, I think it would be pretty fun. And it would also be just endless fodder for videos if people are interested in that kind of thing. Um, then I might also do some video essays on special interests I have, like space tube colonies, insect protein, and freshwater scarcity. But that's probably further down the line. For now, I just wanted to get this vlog out because I haven't updated my website in like 5 months because I've been super busy. So, yeah, if you watched all the way to the end, thank you very much. I really appreciate your time. Everything that I do, that I post, I try to make worth the time it takes to consume. And If you are interested in the stuff that I'm doing or have any suggestions for something for me to work on, just let me know. And if you want a neon sign or some sort of cosplay prop, obviously, just let me know too. All right. Thanks again, and I'll see you guys later.